All right, solving one-step inequalities by multiplying and dividing. If you're like me, you don't like to just know why that something works. You want to know why something works. So you want proof. So I'm going to give you proof. We're going to do an actual example with numbers, and we're going to come, hopefully, to a conclusion for a rule. So if you have an inequality, and you divide the same positive number to each side, it's always going to remain true. Let's show that. So let's say we have the inequality 6 is less than 8. I think we can all agree that 6 is less than 8 and that that is true. Now, what if we were to, like this said, divide the same positive number to each side? So in other words, do 6 divided by 2 and 8 divided by 2. Let's see if that still remains true. So I'm going to write 6 over 2 is less than 8 over 2. I'm going to simplify that. 6 divided by 2 gives us 3. 8 divided by 2 gives us 4. Is that still true? Is 3 still less than 4? Yes. So we're proving this statement true by our examples. Now, hopefully that makes you think a little bit and look for some more evidence. Like, what if we were dividing by the same negative number? Let's do that same example now and do it with a negative. So we're going to write, for now we're just going to say if you divide the same negative number, it becomes, and we're going to figure out if it's true or false. So I'm going to do my same example again. 6 is less than 8. We already know that's true. But what if I were to divide by negative 2 now? 6 over negative 2? Let's see if that's still less than 8 over negative 2. 6 divided by negative 2 gives us negative 3. 8 divided by negative 2 gives us negative 4. Is that still true? If you're questioning it, look at a number line. You got negative 1, negative 2, negative 3, negative 4. The more positive numbers are to the right, the more negative numbers are to the left. So our greater numbers are right. And this is saying that the negative 4 is greater. Well, the negative 4 is the left of negative 3. So it's actually our lesser negatives that are greater. So this should be the other way around. Negative 3 is greater than because it's further right on a number line. So this is false. And now we can go back to our statement and we're going to say it becomes false. This always works. So you could keep on trying examples. You could make up another example or maybe divide them both by negative 4, divide them both by negative 1. Doesn't matter what you divide. If it's a negative number, that's going to switch this. And the reason is, the larger the negative is, the lesser it is, the further left it is on a number line. So why is this the case? We'll just say larger negatives are lesser numbers. And if you ever get confused, just refer to the number line. That means they're further left on the number line. just like we showed here. Negative 4 is lesser because it's further to the left. Negative 3 is greater because it's further to the right. All right, that brings us to a rule. See, now we're just dealing with numbers. Sometimes we'll have variables in there, right? When we solve inequalities. And here's our rule. If you multiply or divide a negative number to both sides of an inequality, you must reverse the inequality sign. And really the key there is it's to both sides. And I'm going to give you an example of this and a non-example. Because I've seen people get mixed up. And on the non-example, they're going to try to make it so it switches, but it really doesn't. All right, so for our example, let's do negative 4x greater than 24, and we just want to solve it. And for our non-example, we're going to do 4x greater than negative 24. Now, if these were equations, they're going to have the same solution, but they're inequalities, so we need to be careful of when do we switch the sign, when do we not switch the sign. So look at the example with me. We can still draw the line right down our equal sign, or inequality sign in this case, and we want to get x by itself, so we're multiplying by negative 4. We need to divide by negative 4. Whatever I do to one side, I do to the other. And look back up at our rule. We did it to both sides, so we must reverse the inequality sign. So these cancel. I get x is less than negative 6. And you can check it too. So to check that, I just plug it back in, and it's got to be true. So the check would be negative 4 times negative 6 needs to be greater than 24. And actually, this check only works to show that it's exactly equal to it. So you can still use the check step on an equality, but it's not going to help you on which way the sign's going. So we'd still check it just to make sure we solved it right, but again, remembering this sign is remembering that rule. And hopefully you know why the rule works now. Okay, look at our non-example. We again draw the line down the inequality sign. We're multiplying by 4 to the x, so we divide by 4. Do it to both sides, and be careful here. You may think, oh, well, I'm dividing by a negative. No, you're not. You divided 4 to each side, positive 4, not negative 4. Don't look at that number and say it's negative, so I have to switch the sign. That's not what our rule says at all. It says you're dividing or multiplying a negative to both sides. So this is going to be x is greater than negative 4. Excuse me, negative 6. Whoops. X is greater than negative 6. And again, we could check it, and that would be, that's just going to check our answer. So 4 times negative 6 needs to be equal to negative 24. And negative 24 equals negative 24, so it checks. Let's make a note on this, that here the sign was reversed. And on this one it was not reversed. And again, it's because we divided by a negative to both sides. That's why we reversed it. And that's why we didn't here. We divided a positive to both sides, so we didn't reverse it. All right, it's time to challenge yourself with a word problem. And for word problems, we want to translate them into a math sentence. So here's our example. The quotient of a number and -6 is at most 9. We should know what some of these words mean. Like I'm looking at the word quotient, and I'm thinking divide. I'm looking at the word at most, and I'm remembering, I hope, if you can be warned at least twice before you get in trouble, or at most twice, let's say, at most twice, that would mean you can't be warned any more than twice, so it would be that much or less. So that's going to be less than or equal to. And I don't know the number, so this number here I'm going to call x. So here's how I'm going to write it. The word and is where I slip in this symbol. So it's going to be x, and that tells me divide by -6 is at most, that's my less than or equal to symbol, 9. And now I have my inequality. Now all I need to do is solve it. So I'm going to multiply by -6, multiply by -6. That cancels here. And remember, I multiplied a negative to both sides, so I need to remember to reverse the inequality sign. And I get -54. To reverse or not to reverse? That is the question. And hopefully you have the answer.